Hi everyone, my name is Tiara Turner. I'm an industrial engineering student who's a senior here at Iowa State. And for those of you who don't know, industrial engineering is essentially one of the engineering programs in which the students look at processes, and we can be doing anything from engineering management to data analytics to ergonomics. So looking at, human health and how to keep humans healthy and safe as they go through different um, productivity challenges or manufacturing processes and operations.
Hi, I'm Jolie. I'm a sophomore in industrial engineering here at Iowa State, and today we are in the WISE office. And WISE is a program here at Iowa State, and it stands for Women in Science and Engineering, right behind us. And it's a program here to help support women in science and engineering. Some services that we provide are study groups, mentoring, and we do this K through 12 outreach as well. So today we are going to be doing an activity called Catch a Rainbow, and we're going to be exploring surface tension by experimenting with milk, food coloring, and dish soap in this activity.
All right, so as she said before, we're going to be looking into surface tension with food coloring, milk, and water, and all that good stuff. But before we get into the fun, we have to verify that we have all the right materials. So take a moment and look in your box or look at your table, wherever you have your things placed out in front of you. And as I read the things off the list, just check to make sure that you have them. All right, so you should have a shallow bowl, can be made of plastic or paper, and there should be at least one bowl per group of two. Also, you should have a pack of food coloring, and it should be a variety pack, so you want to ensure that you have more than one color type. Then you're also going to need one deep bowl for the entire group. You're going to need liquid dish soap, whole milk or buttermilk, and then also one box of toothpicks.
Okay, so we have filled up our deep bowl almost to the top, and now we are going to add 1 drop of red food coloring.
Now stop the video and make a prediction. What do you think will happen when the food coloring is added to water? Once you have made your prediction, you can fill up your deep bowl and add 1 to 3 drops of food coloring and observe.
We just put enough milk to cover the bottom of our shallow bowl. Now we're gonna add 2 to 3 drops of different colors in the milk.
Now is your turn to do part 2. Pause this video and make a prediction. What do you think will happen when the food coloring is added to the milk? Then fill up your shallow bowl with a little bit of milk and add 1 to 3 drops of food coloring and observe. Now take some time to compare the water and milk mixtures. How are they similar? How are they different? And why might they be different? When you are done, you can play this video and see our comparison.
Some notable differences that you can see is that in the deep bowl with the water and the food coloring, the red food coloring is kind of all throughout. We call that diffusion. So basically it's spread out. Whereas in the milk, the food coloring did not diffuse or did not spread out all the way. While the food coloring did spread a little bit, it did not spread in a mixing kind of fashion or form. And if you look closely, you can see that the yellow and the blue, while they got close to each other, they did not exactly mix. If you know yellow and blue mixed together makes green, they kind of just stayed on the outside or the edges. They didn't actually mix together.
Add 1 drop of soap to the milk bowl and see what happens.
Stop this video and make a prediction. What do you think will happen when the soap is added? Once you have made a prediction, you can add 1 drop of soap to your bowl. The toothpicks may come in handy, as you can get a very small drop from the soap bottle to put in your bowl. If you look very closely, you can see the colors drop to the bottom of the bowl and then resurface while being repelled or running away from the soap dot. Is this what's happening in your experiment?
If you notice, the soap is in the center here. That's that light color blue. And essentially, when we first drop the soap in, all of the colors kind of spread out and away from it. And that is because of the hydro, hydrophobic and hydrophilic interactions that are happening. And it's essentially making it so that the food coloring is repelled. The soap is acting as a repellent, and that's why it's all of the food coloring is moving away from it. So the colors kind of hit the bottom, then they resurface, but they're still, doing their best to stay away from the soap. An important note about the water and the milk is that, as we said earlier, the food coloring didn't diffuse in the milk, and that was specifically because, unlike water, milk has fats inside of its liquid, and so the fats are what prevent the food coloring from diffusing.
Stop the video and go through these discussion questions. When you are finished answering them by yourself or with your classmates, you can watch our explanation of some of the answers.
So to summarize what we just observed in the activity, when we added dye to the water, the dye was able to diffuse in the water because of the favorable interaction between the two substances. Dye is hydrophobic, meaning that it repels water. So that's how we saw it kind of move in the water, but you never saw it become a homogeneous mixture. When the dye was added to the bowl of milk, we saw that the dye did not mix with the milk, and this is because milk has fats in it, and those fats entrap the dye so it doesn't spread out like it did in the water. When we added dish soap to the mixture, it caused the surface tension of the milk to break, and then the dye was able to mix in the milk, and we watched it drop to the bottom of the bowl and come back up.
As Joey stated, you saw that the dye went to the bottom and then resurfaced to the top. That process that you witnessed with us was convection. And so with convection, the hotter liquid is inherently less dense, and so it's going to go to the bottom, and it only resurfaces once that temperature of the warmer liquid assimilates to the colder liquid, which in this case was the milk, since it had been in the refrigerator, and the food coloring was just room temperature. However, when we added the soap, at that point, that liquid was of the warmest temperature because it had been sitting out the longest, and the food coloring had already had a chance to kind of assimilate to the temperature of the milk. So it dropped down and then came back up. And you'd also notice in the video that when the soap was added, the food coloring kind of moved away from it, dispersed away to the outer edges of the bowl. And that was because the soap repelled the food coloring, which was hydrophobic in nature, and that's because dish soap has hydrophilic interactions, meaning that it doesn't necessarily repel water and that it is capable of mixing with water. So a lot of these processes that we just talked about, surface tension and convection, are things that we come across in everyday life and also in college with different majors. In terms of everyday life, Cooks and chemists use this in their work, convection especially with cooking. You might notice you might have a convection oven. Now you know what's happening there with the differences in temperatures and density of the materials that's going into the oven. And then also chemists and biochemists deal a lot with surface tension and hydrophilic and hydrophobic materials in their interactions in liquids. And then also some of the things you can major in, if this sounds interesting to you when you're going to college one day, there's chemistry. And in this instance, these experiments that we did, there was also a little bit of thermodynamics, biochemistry, which deals with the hydrophobic, hydrophilic, and amphipathic interactions. And, you know, some cool hobbies that are kind of similar to this is skipping rocks on water. So what allows it to skip?
Real world applications of these concepts is a bug called the water shrider. And a water shrider sits on top of the water and uses surface tension to its advantage to travel around ponds. Another real world example is boiling water. Boiling water also helps overcome surface tension so your food can mix well.
So thanks so much for joining us for the Catch a Rainbow experiment. Again, my name was Tiara Turner.
And I'm Jolie.
And we hope you had a good time. Join us again for another WISE workshop.